Alright guys, just so, I went ahead and put that on there just so you know, these are the questions that I'm going to go over on this video. So, the other video was made for regular, so they had the same, well, most of the questions are the same except for you had an added portion to the test, which was the last section that we did over polynomials, and some of the questions were different. So on their 13, 14, and 15, they had different questions, whereas yours were smaller numbers because you had to do them without a calculator. Number 7 on the transformations is different for yours, so we're going to do that. And 15, 16, 17, like I said. Okay, so let's go ahead and get started on number 13. So on number 13, and my paper's yellow because that's all that was in the printer, so it looks kind of weird. That's why. Okay, so number 13 says to solve this using the quadratic formula, and this NC is to let you know that you're not supposed to use a calculator, okay? So the first thing you want to do is make sure that you have this in the correct format for the quadratic formula, and know that it's always ax squared plus bx plus c, or in this case v squared and v. Doesn't really matter though. The quadratic term first, linear next, the constant last, okay? So this right here, and this needs to be equal to 0. This 2v is on the wrong side. So please don't say a, b, and c. Don't even say a, b, and c. Get that 2v over there first, in the middle, and the only way you move it is by subtracting it. Okay, so I know a is 4, b is negative 2, and c is 1. So let's talk about quadratic formula. X equals opposite b plus and minus the square root of b squared minus 4ac all over 2a. Now I'm probably not going to be giving that to you, so you need to, at this point, have that memorized, okay? So, in this case, v. So v equals opposite b, so the opposite of negative 2 is positive 2, plus and minus the square root of b squared. Now you can write negative 2 squared, but you better not write this, because if you type it in like that, you're going to get a negative 4, and that's wrong, because anything squared is positive, right? So you can write that. Well, you're not even typing anything in anyway. I'm just saying, make sure you remember that negative 2 squared is positive. So minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 4. Okay, so in doing this problem, I need to, without a calculator, I'm going to try and simplify this inside. So what's negative 2 squared? Well, I think what's negative 2 times negative 2, and that's positive 4. Okay, minus. I don't even think about the minus whenever I multiply these, and then I just combine them, okay? 4 times 4 is 16. 16 times 1 is 16. So what is 4 minus 16? We'll think about 16 minus 4, and that's 12. So 4 minus 16 is negative 12, okay? So here's what you've got. 2 plus and minus the square root of negative 12 all over 8. Okay. Now you have to be careful right here, because I've got some people that try and go ahead and simplify the 2 and the 8 by saying 1 plus and minus over 4, and then they've got the square root of negative 12, and whatever they do with that, right or wrong, it's still wrong. You have to remember that if you've got two different things in the numerator and you're dividing by 8, that means you're dividing every term by 8, okay? Not just the 1 or not just the 2. And that's what happens when you do that. So it's kind of like saying 4 plus 3 over 2. If you try and do that, just 4 divided by 2, then you say 2 plus 3 over 1. So that remains unchanged, just like this. Well, 2 plus 3 is 5, and 5 divided by 1 is just 5. 4 plus 3 is 7, and 7 halves is not 5. Okay? Those are not equivalent. You cannot simplify that. So that's a big no. Some of you are like, I already know that. Oh well, I'm just going over it. Okay? So, first off, can I have a negative under a square root? No. So I'm going to make that positive and put an I on the outside. Okay, you always also need to check, is there a perfect square that divides out of 12? Okay? Now the only perfect squares less than 12 are 4 and 9. So does 4 divide into it? Yes, 3 times. Is 9? Not evenly. So I'm going to say 4 times 3. Okay. So this is the square root of 4 times 3, right? So I take the square root of 4, and it's 2. So I put a 2 on the outside. I cannot take the square root of 3, and then I put the I on the outside, all over 8. Now, this 2, and this 8 can be simplified. 2 divides by itself one time, goes into it twice, or goes into it once. 2 divides by 2 once, 8 divides by 2 4 times. So final answer, 1 plus and minus the square root of 3, I over 4. Okay? It doesn't matter if the I is in the front of the square root or in the back. It's just got to be there somewhere. Okay? So now let's do 14. Okay. So, not in standard form, which means I need to subtract the 2. X squared plus 4x minus 2 equals 0. So x equals opposite b. So opposite b would be opposite of positive 4, negative 4, plus and minus the square root of b squared. So 4 squared is 16. I'm going to go ahead and write that in there, b squared, minus 4 times a, which is 1, times c, which is negative 2. Now, if there's something that people miss, it's that negative right there. You have to remember to put it, but then you also have to remember to think about it. 2 times a, which is 1. Okay, so a couple of different ways to do this. Negative 4 plus and minus. Now, when you think about this, 16, you can either deal with the negative now, the minus, or leave it. If you just write minus, then forget it and just do this right here. 4 times 1 is 4. 4 times negative 2 is negative 8. So that's 16 plus 8, right? 16 plus 8 is 24, so you could say 24. The other option is go ahead and do negative 4 times 1, which is negative 4. Negative 4 times negative 2 is a positive 8, but remember that that was minus, so the fact that you took the negative with it means you're left with addition, so you're adding 8, okay? So either way, 16 plus 8, and you get the square root of 24 over 2. Okay, so the square root of 24. So when I think about 24, I think about, is there a perfect square that divides out of 24? And in fact, 4 goes into it 6 times. So I take the square root of 4, and I'm left with 2 on the outside. I have to leave the 6 on the inside, and I'm dividing by 2. Well, these three numbers all divide by 2. So that divides by 2 twice, that divides by 2 once, that divides by 2 once. That's a negative 2. So negative 2 plus and minus. You can write the 1, you don't have to though. So square root of 6 all over 1. Do I have to write the 1? No. You could write negative 2 plus and minus the square root of 6. And call it good. Okay, either one is correct. Okay? Let's move on to question 15. So question 15. Again, put it in standard form. X squared plus x, and then minus 20 equals 0. Okay, so x equals opposite b. B is positive 1, so negative 1, plus and minus the square root of b squared. Change, okay. So b squared, 1 squared is 1, minus 4 times a times c, all over 2 times a. Okay, so x equals negative 1 plus and minus. So I've got 1 minus, or plus, doesn't really matter. I said or plus because of the negative and the negative. If you want to go ahead and do that, negative 4 times negative 20, well, 4 times 20 is 80, right? So it's going to be plus 80. Okay? So when you think about, if you see 2 negatives, make it a positive, okay, because you're adding. So that's the square root of 81 all over 2. Okay, so square root of 81 is 9. So I've got negative 1 plus and minus 9 over 2. You cannot stop there. You cannot stop there. You can get partial credit when you stop there, but you will not get full credit because you have to recognize that that is 9. No square root left over. But that's not done. These two numbers can be simplified. So I've actually got negative 1 plus 9 divided by 2 and negative 1 minus 9 divided by 2. So negative 1 plus 9 is 8, and 8 divided by 2 is 4. Negative 1 minus 9 is negative 10, and negative 10 divided by 2 is negative 5. Now, if these are whole numbers, then that meant the whole time I could have factored. So if I think about the factors of negative 20 that add up to 1, then they are 5 and negative 4. X plus 5 and x minus 4. But the only time this equals 0 is when x equals negative 5 and x equals positive 4. Okay? Now, that being said, if you see that it factors, can you factor it? Sure, to get the answer, but you will not get credit for the work. And you have to show it using the quadratic formula. So make sure you do the quadratic formula. Okay. So number 7. Okay. Number 7 is different in that you have that negative on the inside, yeah? So when you think about your transformations, you have to think about, because you're going to be, if they're not both there, then you have to know which one is which. When I think about the negative in front of the x, then I'm switching x values. So if it was a positive x, now it's a negative x, right? Well, that shows you right there that you're going to reflect over the y-axis, okay? Now, do you agree that if I have a negative in front of my f of x is usually another way for saying y. That's just the, if I said f of x equals 7x, you would understand what I meant. And if I said y equals 7x, they're both functions, right? So when I say negative y, that means whatever y value I had, now it's negative, or if it was negative, now it's positive, right? But I'm flipping over the x-axis, okay? So the fact that I have both of them, and remember, we have to work from the inside out. I'm going to reflect over the y-axis first, okay? Then it says a negative on the outside, so I'm going to reflect over the x-axis. And then we have minus 2 on the outside. Now, and I'm sure Mr. Hines talked about this in his video, but as far as transformations go, remember that you already know a lot about transformations when you talked about quadratics and vertex. So if I said x plus 3 squared minus 2, you knew the vertex is at negative 3, opposite on the inside, and then negative 2. Which means on the x-axis you went left 3, so opposite on the inside, left, because it's an x value, and then down 2, because the y value is negative 2. So you already know that means go down 2. Okay? Now what am I flipping and moving down? Well, this original function. So what I need to do first is sketch that function. And I think I'm actually going to remember this. Negative 5, 5. Okay. So the original graph, 1, 2, 3, 4, 5, 1, 2, 5. Now, you don't have to, but it's a good idea to go ahead and sketch the original, even if you do it with dotted or a different color, whatever you want to do on the test, I don't care, but the best idea is to start from the original and go there, okay, and do your transformations, because you're less likely to make a mistake if you already have the dots on there. So the first thing I'm going to do is reflect over the y-axis. Well, so this part right here is a little bit weird, but so I'll start with this one. On this one, I'm going to the left 5, which means now I'm going to go to the right 5. 1, 2, 3, 4, 5. Okay. This is to the right, or to the left 3, so now I'm going to go to the right 3. 1, 2, 3. Now these 2 points, they're reflections of each other, so that means this one would be here, and that one would be there, which means I've got this shape now. And remember, it should look like a mirror image of each other, so sometimes people start doing this way. That does not look like a mirror image, so you got to make sure that you understand, okay? So those are my new points. Okay, so reflected over the y. Now I need to reflect over the x, which means I need to flip them this way, okay? So if this is up 1, 2, 3, 4, then I need to go down 1, 2, 3, 4. Again, down 4. Up 2, so down 2. Up 5, so down 5. Okay? Connect in the same manner. I'm still not done though, so I'm going to do dotted. Okay? It looks like a reflection of that across the x-axis, so I think I'm doing good. And then the last step, I need to shift it down 2. So I'm going to take each point and go down 2. And then solid. Now, it's okay if you connect these to solid, as long as you label which one is your answer, okay? Or I'm able to tell that that's your answer. So they said h of x, so I'm going to let this be h. Okay? All right, so now let's use that graph to answer these questions. What is the value of h of negative 1? Well, h of negative 1 means I'm going to go to negative 1 when x equals negative 1. So when x equals negative 1, where is the function h? It's down here at 1, 2, 3, 4, 5, negative 6. Okay? So negative 6. So where's h of positive 3? So 1, 2, 3. That means I'm at negative 1, 2, 3, 4. Negative 4. Okay? On what interval is h increasing? Okay. So from negative, remember on increasing and decreasing, only x values and only parentheses, never brackets, okay? And never y values. Y values tell me what I'm doing. Interval means where am I doing it. So this is negative 1 to 1, and we are remaining constant, okay? From 1 until 3, the function is actually increasing. So that's going to be my answer. So as far as increasing, I'm going to say parenthesis 1 to 3, close parenthesis. Okay? Only x values, only parentheses. What is the coordinate point of the absolute maximum? So on this green function, the highest point is that point right there, which is the point 3, negative 4. Okay? All right. Now we're going to do the last 3 questions on the review. Okay. So I'm going to grab my calculator. Determine the degree of the function with the following set of data, and then determine the equation in standard form. Okay. So first I need to determine if this is linear or quadratic or cubic, and it's not going to be quartic because we haven't practiced one like that. You don't know how to solve that yet. You will, but not yet. Okay. Very important. You need to make sure that when you find differences, so a lot of times we do it vertically, and I'll go ahead and do that this time, but you can also do it horizontally, so it's just whatever. So I'll go ahead and show you in case you prefer. 0, 1, 2, 3, 4, and 5. Negative 1, 2, 9, 32, 33, 174. Okay, so when you're finding your first set of differences, you have to remember to work from the second to the first, okay? So you have to do this one minus that one. You cannot do first minus second. It has to be second minus first, third minus second, fourth minus third, okay? Why? If you work backwards, then you're going to be changing signs, and you know, you can't have numbers going up when your function has you going down, okay? So you got to be careful about that. So what is 2 minus a negative 1? Well, that's the same thing as 2 plus 1, which is 3. 9 minus 2 is 7. Okay, 32 minus 9. This is going to be in the calculator portion. So 32 minus 9 gives you 23. 83 minus 32 gives you 51. And 174 minus 83 is 91. Okay? So we find our second set of differences. 7 minus 3 is 4. 23 minus 7 is 16. 51 minus 23 is 28. I should have known that one. And that one's 40. Okay. So let's find our third set of differences. I'm going to keep going until they're the same. 16 minus 4 is 12. 28 minus 16 is 12. And 40 minus 28 is 12. Which means to me that this is a cubic polynomial. Okay? So I know that my standard form is going to be ax cubed plus bx squared plus cx plus d. Okay, let's talk about what we already know. In general, cubic polynomials have a third difference of 6a. It's always 6a. In a quadratic, it's 2a, the second differences. And in a cubic, the third differences are 6a. In a quartic, it's 24a. But since we're doing a cubic polynomial, I know that 6a has to equal my difference, my third difference, and that is 12. So that means a equals 2. So divide by 6 and I get a equals 2. So I already know that. So 2x cubed plus bx squared plus cx. And now I can actually solve for d as well. Just using this right here, some of you might already know the answer, and that's great. If you don't, then think about it this way. If I use this coordinate point, 0, negative 1, that's an x, that's a y. I'm going to fill in those coordinate points right here, or those coordinate points, those values right here. So y is negative 1, and if I plug in 0, 0 cubed is still 0, and 0 times a is 0, plus 0 squared times b is 0, 0 times c is still 0, and then plus d. So what I get is that all of this doesn't matter, d equals negative 1. No matter what, your constant term on your polynomial is always going to be your y-intercept, okay? So if you have your y-intercept in your table, you already know what the constant term is. In a quadratic, it's c. In a cubic, it's d. So I know d equals negative 1. So minus 1. Okay? So we have half of our polynomial. We need b and c, yeah? So what you should always do is pick the next 2 points, 1 and 2, and 2, 9, right? So first I'm going to use the point 1, 2, and then I'm going to use the point 2, 9 to come up with an equation, or come up with 2 different equations involving b and c. I know I have to do it twice because just once will not solve for b or c. Okay, so this is my x, this is my y. 2 equals 2 times 1 cubed plus b times 1 squared plus c times 1 minus 1. 1 cubed is 1. We're not doing 2 times 1 cubed, as in it's not this. Okay? That is not the same thing as this. This is what's being cubed, 1 cubed, and that's 1, and then you multiply that times 2. So I've got 2 equals 2 plus b times 1 squared, that's just b, times 1, which is b, plus c times 1, which is c, minus 1. 2 minus 1 is 1. So in general, I've got a 1. And if I subtract that over, then I've got 1 equals b plus c. Okay, so that's my simplified equation. So now I'm going to do the same thing, but with the next point, 2, 9. Okay, so the y value is 9. So right there, for y, I'm plugging in 9. And for every x, I'm going to plug in 2. So I've got 2 times 2 cubed plus b times 2 squared plus c times 2 minus 1. So I've got 9 equals 2 cubed is 8, and 8 times 2 is 16. 2 squared is 4, so 4b, 2c, minus 1. Okay, so if I say 16 minus 1, I get 15, and if I subtract 15, so if I subtract 15 now from both sides, those go away. 9 minus 15 is negative 6. So then I've got negative 6 equals 4b plus 2c. Okay. These are the 2 equations that I'm going to use to solve. So I'm going to rewrite this in terms, or b plus c first equals 1, and 4b plus 2c equals a negative 6. Now you might notice that this equation right here, all of the numbers are even. So if you wanted to, you can make your life a little bit easier and do b plus c equals 1, 2b plus 1c equals a negative 3. But if you see it, great. If you don't, then just go ahead and work with it as is. Okay? So let's pretend like you didn't see that. I need to either cancel out the b's or the c's. It's kind of up to you. Well, if I want to cancel out the b's, then I'm going to multiply the whole numerator by negative 4, so negative 4 and positive 4 cancel each other out. If I want to get rid of the c's, then I'm going to multiply the whole numerator by negative 2. Okay, that's elimination. The other option is you could solve for b and say b equals 1 minus c. And if b equals, I guess I gotta write that down. If you wanted to, you could solve for b by subtracting c over and say b equals 1 minus c. And then use in your second equation 4b plus 2c equals negative 6. In place of b, you could substitute in 1 minus c. So 4 times 1 minus c plus 2c equals a negative 6. Okay? That's substitution. You would distribute your 4, simplify, solve for C. Okay? So substitution is always an option. I had another student say, could I set them equal to each other? And I said, well, sure, if you solve for B here and then you solve for B there. Solving for B would not be the best choice, though. Solving for C on both would be, because you could divide everything by 2. But anyway, I'm going to go ahead and cancel out the C's, the smaller number. So I'm going to multiply the whole top equation by -2. So I'm going to rewrite the bottom equation. You don't have to, but I'm going to. And now I'm going to multiply by 2. -2 times B is -2B. -2 times C is -2C. And -2 times 1 is -2. Now, a lot of people ask, or a lot of kids ask at this point, do I add or subtract? Well, I would say, well, the only way that these two cancel each other out is if you add them. So added up, those give you 0. 4 plus a -2 is 2. And -6 and -2 is a -8. Okay? So then if I divide by 2, then I get B equals a -4. Okay? Well, if B equals a -4, then I'm going to go back to this equation right here. B plus C equals 1, right? So B, which is -4, plus C equals 1. So if I add 4, then C equals 5. Okay. So, I know A, I know D, now I know B, and I know C. So final answer, y equals A, which is 2, x cubed, plus B, which is -4, x squared, plus C, which is 5, x, plus D, which is -1. And there you go. Okay? Alright, so this is not, it's not a difficult process, it's just a process that you need to practice a few times and make sure you understand, okay, after I do this, I need to do this, and after I do this, I need to do this, and I know this because of this, okay? So different things you're going to have to remember. Okay, so let's do 16. Okay, so remember, I'm just going to go ahead and do these like this. So remember, you have to do second minus first. So I've got -1 minus 3, which is a -4. 15 minus a -1 is 15 plus 1. 51 minus 15 is 36. I knew that. 107 minus 51 is 56. And 183 minus 107 is 76. Okay? And while you could do those in your head or by paper, since you're going to have a calculator on here, use it just so you can make sure that you don't mess anything up. If you do this and you find that all your, at some point you don't get all the same number, then something's wrong. Okay, 16 minus a -4 is 16 plus 4, which is 20. 36 minus 16 is 20. 56 minus 36 is 20. And 76 minus 56 is 20. So the fact that the second differences are the ones that are the same means to me that this is a quadratic polynomial, okay? So the fact that it's quadratic means I need to find just A, B, and C. Okay, so here's what I've got. I know that in quadratics, the second difference is always 2A. So in general, second differences in quadratics are 2A, just like third differences in cubics are 6A. So 2A equals, what's my second difference? 20. So that means A is 10. So y equals 10x squared so far. Okay, I also know that C is my constant, right? And if this is 0 and that's 0, then that's 3, so C equals 3. Using the point 0, 3. 3 equals 0 plus 0 plus C, and there you go. Okay? So then I've got plus bx plus 3. Okay, I need to solve for b. Now, solving for a quadratic is actually a lot easier than a cubic because there's only one unknown, which means you only need to plug in one more point. I'm going to plug in the point 1, -1. Okay? This is my x, this is my y. So for y, I'm plugging in -1. For x, I'm plugging in 1. 10 times, well, 1 squared is just 1, and 10 times 1 is 10. Plus b times 1, which is just b, plus 3. So I've got negative 1 equals 10 plus b plus 3. 10 plus 3 is 13, and if I subtract 13 from both sides, b equals a negative 14. Okay, so y equals 10x squared minus 14x plus 3. Okay, you could also check yourself. It's a good idea. If I go ahead and go to my y equals and I type in 10x squared minus 14x and then plus 3. And then if I go to my table, at 0 I get 3. At 1 I get negative 1. At 2 I get 15. At 3 I get 51, 107, 183. That means I'm right. That's good. Let's go ahead and check this first one, just to make sure. 2x raised to the third minus 4x squared plus 5x minus 1. Go to my table. At 0 I'm negative 1. At 1 I'm 2. 2 I'm 9. 3 I'm 32. 4 I'm 83. 5 I'm 174. Perfect. Okay? So you can check and make sure you got it right. Alright, so let's do 17. Okay. Negative 1 minus a negative 6, minusing a negative 6, adding, so negative 1 plus 6 is 5. 30 plus 1, because 30 minus a negative 1. So 30 plus 1 is 31. 111 minus 30 is 81, I'm pretty sure. 111 minus 30, yep, 81. 266 minus 111 is 155, and 519 minus 266 is 253. Okay, let's do it again. 31 minus 5 is 26. 81 minus 31 is 50. 155 minus 81 is 74. 253 minus 155 is 98. Okay. If I subtract again, 50 minus 26 is 24. 74 minus 50 is 24. 98 minus 74 is 24. Okay. So that took 1, 2, 3 differences, which means it is a cubic polynomial again. Okay? So y equals ax cubed plus bx squared plus cx plus d. So that's where we're going to write our final answer. Okay, so third differences are always 6a in a cubic polynomial. So 6a equals 24, a equals 4, divided by 6. Okay, so I already know that's 4. The y-intercept, 0, negative 6, is always the constant term d. So I already know that that's going to be minus 6. D equals a negative 6. And then at this point, what I need to do is take they could be two random, but you definitely don't want to be using those. So I'm going to use these 2 points, right? And I'm going to plug them into the equation with what I have so far. And then we're going to figure out b and c using systems of equations. So first I'm going to do 1, negative 1. This is x, this is y. Okay, so y equals, so negative 1 equals a, which is 4, x, nope, just kidding, x is 1. Okay, so x is 1. Cubed. Okay. So 4x cubed plus bx squared, so b times 1 squared, plus c times x, which is 1, plus d, which is minus 6. Okay. 1 cubed is 1, so this is negative 1 equals 4. 1 squared is 1, so plus b, plus c, minus 6. 4 minus 6 is a negative 2. So if I'm going to add 2 to both sides, then I'm left with 1 equals b plus c. Okay? So all I'm doing is combining these to negative 2, and then I'm adding 2 to both sides. Okay? Now let's do it again, but let's do it with a point 230. So that's my x, this is my y. 30 equals a, so 4, let's do it again. 4x cubed, so 4 times 2 cubed, plus bx squared, so 2 squared, plus c times x, which is 2, plus d, which is minus 6. Sorry, I'm off the page. Okay, so 2 cubed is 8, and 8 times 4 is 32. 2 squared is 4, so plus 4b, plus 2c, minus 6. You might have noticed that if we give you the data sets 0, 1, and 2 every single time, then it's always going to be b plus c equals some number, and 4b plus 2c equals some number. b plus c equals some number, 4b plus 2c equals some number. But anyway, okay. 32 minus 6 is 26. And then if I subtract 26 from both sides, then I'm left with 4. Okay, so I'm going to take these two equations. So 4 equals 4b plus 2c. 1 equals b plus c. I could have rewritten them, but oh well. And this time I'm going to do substitution. Might as well. I know I started it up there, but I'll go ahead and do it. I'm going to solve for c. So that means I'm going to subtract b from both sides. So c equals 1 minus b. So substitution means I'm going to take what c equals and substitute it into the other equation for c. So 4 equals 4b plus 2 times 1 minus b. So I've got 4 equals 4b plus 2 minus 2b. If I minus 2 from both sides, I'm left with 2. 4b minus 2b is 2b. Divide by 2, b equals 1. Okay? So if b equals 1, and that means c equals 1 minus 1, which is 0. So, over here, b equals 1, so then plus 1x squared, or just plus x squared. And c equals 0, so I actually don't have that term, right? And I could leave it like that, but that's kind of ugly. So I'm just going to go ahead and rewrite it. Y equals 4x cubed plus x squared minus 6. And let's go ahead and make sure on that. So y equals 4x cubed plus x squared minus 6. Go to my table. 0, negative 6. 1, negative 1. 230, 3, 111, 4, 2, 6, 6. There you go. Okay. All right. So that is that. Hopefully that will get you through the whole review. And if you have any questions, feel free to come in early in the morning and ask them before your test, or come in during lunch or anything like that, okay? All right. Good luck.